I'm not sure if anyone really has ever invented a better mousetrap, but they have certainly come up with a better mouse. This, for example, is the PowerMouse from ProHands being used in this cytogenetics lab. It has 40 programmable mouse buttons. It's just one example of the continuing effort to try to find a better way to input information or commands into a personal computer. Today we'll take a look at some of the newest computer input devices, the mouse, and more on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SPA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix.
Welcome to the Computer Chronicles. I'm Douglas Nichols, standing in for Stuart Chaffee, and with me this week is Tim Baharin. Tim, welcome to the show.
Thank you.
We're doing input devices today, and I've got something I think you're going to like. This is a mouse pen, and really it's a mouse shaped like a pen. It comes from a point down in Paso Robles, California, and on the flip side of this little device, if you take a look here, you can see the mouse ball.
Okay.
Here's the clicker right there. I can go into this paint program. I can draw a couple quick boxes here. I can grab the fill pattern, I can grab a color, I can fill it in there, I can grab another color, I can come over here, I can fill it in. The question I have for you is, you've got mouse, you've got the mouse pen, you've got touchscreen devices. What is the driving force behind all these new input devices?
Well, these are being driven by the fact that graphical user interfaces are becoming much more popular. Windows 3.0 from Microsoft has come out and sold over 1 million copies. We've had the Macintosh out now for 7 or 8 years and with over 4 or 5 million Macs on the market. And basically, everyone has different ways that they like to use a cursor control, and as a result, they are looking for other options. And some people like the mouse, some people don't. And today, we're going to look at other products similar.
All right, today we're going to see the very latest from Microspeed, from Mouse Systems, from MicroTouch, and from Elographics. But first, we sent our cameras to meet the art director of a San Francisco ad agency that employs a Wacom cordless digitizer. We have this report.
Computers may never replace the artist's eye for detail, but using a digitizer tablet and stylus, artists at the San Francisco ad agency can recreate their original work on computers without missing a line. This tablet from Wacom emits a series of signals that are stored by a passive circuit in the cordless stylus. The stylus re-emits the signal at varying frequencies, depending on the pressure applied by the user. The grid then picks up the transformed signal and translates it into a point on the screen. This technology makes tracing artwork possible, and depending on the software used, it even lets the artist manipulate minute details on a color photograph.
This allows me to go right from the stylus, tracing something on the stylus and the pad, right into the computer, and that allows me a little more room to be quicker to what I want to achieve. I could get an exact concentration of, not to sound cosmic, energy in a certain area, and not have to keep going back through and recreating it to change it.
The tablet is a mere 1/4 of an inch thick and weighs less than 2 pounds. The stylus does not require batteries, and users click on the tip to activate menus and dialog boxes. While the stylus may feel foreign at first, Vasilakis says it's the closest thing to an artist's pen and just as easy to use.
The biggest advantage to me as an art director is I could create articles or photographs to what I want to use them in ads and in publications exactly how I want to show the client. It cuts out time and it cuts out a lot of extra work.
For the Computer Chronicles, I'm Kate McGargy.
Apart from the keyboard, there's no question that mouse pointing devices have become the most popular. Here to show us the latest technologies in the mouse and trackball category are Tim Berry, CEO of Microspeed, and Tony Rodriguez. He's the product marketing manager with Mouse Systems. Tim.
Tony, mouse pointing devices are becoming very popular these days, and you're seeing them just about everywhere. Tell us a little bit about that market and why it seems to be growing so fast.
On the PC side, the advent of the graphical user interface, environments like Windows and DeskView, have really been driving mouse sales.
Well, how about the trackball?
Same basic driving force. The graphics environment, as it gets bigger and bigger, more users require input devices, and the more options they require just by natural selection. This trackball was developed by us over the last year and a half after research with thousands of our users of our old design product. It features several major advances in design ergonomics for use. Primary to this are, first of all, it uses an extremely large button so that users can select items on the menus or with their software with either the thumb, which they can click down here, or all the way up to their fingertip and get a nice constant force all the way along the edge of the button.
Basically, they can't miss it.
They basically can't miss it, correct. The other major design feature that we incorporate is quite a large ball compared to some of the trackballs that you'll see out there on the market. Our research showed that the larger ball, which has more mass, is much easier to control, gives the user greater precision in screen operations. And finally, the major design advantage is the ergonomic shape of this compound curve, which is designed to fit the natural shape of the user's hand to minimize wrist angle and wrist strain and eliminate carpal tunnel syndrome and other, repeated action injury.
I think you hinted that these are a little easier to use. Does it require a little less hand-eye coordination, for example? Because the reason I asked that question is these were much more popular in the game arena.
The key benefit is that you don't have to find it. It's a stationary device. It's placed by the keyboard. You never have to move it, so you don't have to look for it and distract yourself when you're using it on the screen.
Why don't you give us a little run-through on the micro speed?
We're running it in Windows 3.0 here, and you can see basically on the screen, my hand resting on the device, the cursor motion. If we want to select an option, just as with the mouse, we use the buttons to bring up an option. One of the features we've added to the device is an automatic drag lock, which allows you to basically click onto an item and move it, and at the same time never have to hold down the button. This makes it much easier to control, especially in things like desktop publishing where you want to place a picture or a drawing in a specific spot.
Just leave it there.
Yeah, just leave it there. Sometimes when you're trying to concentrate, momentarily your finger will slip off the mouse button and you'll drop it where you didn't really want to use it.
Well, how about the problem that I have with the mouse is that maybe I'm going from one side of the screen to the other, and I have to keep going back and forth over the same spot on my desk. Now, how does it?
Exactly. The trackball is a stationary device, and you can see we get to the margin, the cursor disappears, but there's no requirement to bring the device or move the device. I have it set up here to run in a standard application like SuperCalc, and I can show you how, compared to a mouse in a environment.
And how much is that particular trackball?
This trackball is retail. This is a serial device. We manufacture them for serial bus, PS2, Macintosh, and this happens to be a $119 retail.
Well, there you have it.
And now you can see in the spreadsheet, normally when you hit the border, you have to bring the mouse back or move it around. You can see I can just scroll the trackball across the screen very quickly, or up and down very quickly, without my hand ever having to move on the desk. So it's exactly where I place it.
I can see that works very well for a spreadsheet specifically. And Tony, I'd like to talk about the mouse technology, because what I sense here, and maybe I'm wrong about that, but you seem to lack some of the very specific and very finite location that you might be able to get with a mouse. Now, am I wrong about that? Can you do that? Can you get very specific? Can you pick out a pixel for that matter?
Oh, absolutely. In fact, CAD applications, pixel by pixel, is one of the best applications of the trackball.
All right, so Tony, I want you to tell me, if you would, please, what does the optical technology buy me that we haven't just seen in the demonstration with the trackball, for example?
Okay, back in 1982, Mouse Systems made the first mouse for the IBM PC. It was based on an optical technology. The technology uses light instead of a rolling ball to detect motion.
So the first one was then was an optical with an infrared beam or something? Is that
correct?
Okay.
Our first technology used both infrared and visible light to detect motion, to detect vertical as well as horizontal movement. Our latest generation, our PCMouse III, uses what's called M5 technology, which uses only infrared light. It uses light reflected off of a reflective pad.
Which is a very special pad, right?
Correct. This pad has lines on it. So the way an optical mouse works is, as you move it across the pad, it counts lines, either vertical or horizontally, and translates that into motion on the screen.
Show us what it looks like on the screen.
Okay, as you can see, we've got the mouse working in a paint program. Some of the benefits of optical technology are very high precision and accuracy. I can come in here and I can draw.
I can edit fat bits very quickly.
Correct. Right now we're using the mouse in the 3-button mode. Some people say, does a mouse need 3 buttons or 2 buttons? In this application, the third button actually is the zoom feature, the fat bit feature. We can also call up our control panel over here and reassign our mouse buttons.
Customize it on the fly.
Correct. So if I'm a left-handed user, for example, I can change the right and left-hand mouse buttons to where my primary actuator is for the left hand. What I can also do here is change the
speed in which you're going to be able to move it, cursor?
Correct. One thing I can do is also change whether my mouse acts as a 2-button or a 3-button device. By flipping the switch on the bottom of the mouse, now you can see my control panel only has 2 buttons on it. As we said earlier, we can also change the speed of it. I can go faster or slower. So as I lower the speed down, now when I move my cursor,
There it is. There's a cursor.
if I move it takes a lot of movement in order to get cursor back and forth across the screen, whereas if I had high acceleration, I'd use a very small portion of the pad space.
Now, why is this precision so important to us?
Applications like CAD and desktop publishing that require precision and accuracy are really a driving force. A lot of CAD workstations use optical mice. A lot of desktop publishing workstations use optical mice. The benefits of optical technology, in addition to accuracy and resolution, are also reliability. The mean time between failures on an optical mouse is about 20 years.
Now, is this more powerful than some of the stuff we've already seen today?
It's more powerful to a point, but it's just a different technology. Trackballs are good for pointing out, picking pixels out, or defining lines in a screen, whereas a lot of people prefer mice for doing freehand drawing because it mimics the person's movement when they use a pencil or a pen. So it's not really better, it's just a little different.
What's the price on the optical mouse?
The PCMouse III by Mouse Systems is $169.
How about the trackball?
$119.
Yeah, I was going to ask one more question about the trackball. How many of these are we going to be seeing? Are they going to be bundled with other hardware, or is this something that somebody's always going to have to buy at a hardware store? Because usually the mouses are coming bundled.
I think you probably see it remain an option. I think it's the volume on mice is so much higher that the OEMs can buy them for much lower prices. Trackballs are still a little lower volume.
Thank you, Tim, Tony. Appreciate having you here. While much of the focus on input devices is on the alternatives to keyboards, many companies have been focusing in on improving the keyboard. We have a report on 2 such products from the Mac User Labs in Foster City, California.
Keyboards have come a long way from the clang and clatter of old typewriters like this famous Royal. Manufacturers are now competing to provide users with flexible layout and input capabilities. One such example is the switchboard from DataDesk, which works with both IBM PCs and Macintosh computers.
The key features of the switchboard are its modularity. You have these different modules that make up the keyboard, and they can all be rearranged to suit your needs. For instance, if you're left-handed, you can put the function keys and the trackball over on the left side. Or if you want more function keys, you can add more function keys. The key is flexibility.
The modular switchboard comes with separate numeric, alpha, and cursor keypads. They can be moved around by simply disconnecting the ribbon cables on each module. In addition, users can also add a trackball with cursor keys and a vertical function key module to supplement the switchboard. While not a modular design, but different in its own way, is the OmniMac Ultra from Northgate. This Macintosh keyboard offers dual sets of function keys and an extra down arrow in the cursor control pad. A useful improvement is a lock for the comma and period keys. Instead of getting greater than or less than symbols with the lock key, users can type periods and commas even when in the shift mode. Both keyboards focus on ease of use, and that will continue to be the primary consideration in future development.
I think what you'll see is the problem of ergonomics addressed. You'll find that people that are spending many hours at the keyboard will soon complain of various problems associated with long-term use, and you'll see ergonomic issues addressed, where you'll find different shapes, perhaps palm rests, the shapes of trackballs.
For the Computer Chronicles, I'm Kate McGargy.
Some hardware designers have argued for years that the most intuitive input device is the human finger. Here to show us the latest in touchscreen technology is John Carlson. He's the Director of Marketing for Elographics.
John, touchscreen technology has actually been around for a long time, but never caught on. Why is it going to catch on now?
I think there are a number of reasons for it. One is the availability of PCs. Another is that people are becoming more aware of the power of touch systems and the flexibility that it offers for soft menuing for developers, and graphical user interface software like the Windows 3. Touch is a very graphic-oriented medium, and it's a natural fit with these programs.
But it's not quite as precise as the mouse ball or the trackballs we've seen so far today.
Well, it's not quite the same now. It's the resolution, in fact, is 4,000 by 4,000 in this case, but you're using it with your fingers, so it's usually larger target buttons that are put up with the system.
Why don't you give us a little run-through on how it works?
Sure, I'd be happy to do that. Let me first explain that the monitor has the touchscreen overlay added to it and the controller in it. And then we have what we call MonitorMouse software, which is the interface we have into Windows. And once that is loaded, the system runs with Windows just like the normal Windows program. So we have mouse emulation of things like double-click. If we want to drag and slide.
This looks like a good waste of time, by the way.
Oh, this takes hours to do this, that's right. So really the features of the mouse are emulated with the touchscreen, so we could be on a roll here and get this going.
Now this technology, of course, would be real nice in demonstrations for kiosks and point-of-information systems. How do you sell this type of a product?
Well, we do sell to those people, the systems integrators that develop systems for kiosks and so on. We sell to OEMs that have a product that uses the touch systems.
But if I'm a customer and I want to use this type of technology, what's that going to cost me?
Well, a monitor like this, which is fully integrated with the touchscreen, runs about $1,500 to $1,600. We also sell the components, just the touchscreen and the controllers and software, and that goes for about $500 to $600 if you want to integrate it yourself.
You had some more applications that you wanted to show us on there, and
yeah, let me show a couple of things here. One is that for things like calculators, you just point and touch. It's a very natural type of action with the touch screen. And let me get to some other demos that we have here to show some of the types of applications and the graphic nature of it. As it comes up here, let me bring up one thing, and maybe Tim, are you a piano player?
No, but we'll
He's
try
gonna
it.
be.
We're
Let's
going
put
to try
that
it
way.
anyway, okay? Let's see.
Notice how he's just pointing and touching, and that's the action. It's very natural. There's no hand-eye coordination required on it. Let me bring up another thing that we have some people who do home control systems of it. For example, you want to set the time on your sprinkler system, the start time or the ending time. You can just do something as simple as that.
go ahead.
It's used in process control systems too, and we have a little example of what that might be, is where you can, for example, here, change the settings on it. It makes it very graphical for the operator of the system.
I'm curious about how this might fit into the personal computer neighborhood. The way people usually use computers with word processing, with spreadsheets. Is that something that the people are going to have a use for?
I think primarily the use of touch is for a casual user. Things like point of sale. It's not for the major user of the computer itself, but for a kiosk or training system, something like that, where you're not actually running the computer per se.
Point of information, point of sales probably has a great application.
Right, multimedia.
Absolutely.
That type of application.
John, thank you very much. When we come back, we'll take a look at touchscreen technology on the Macintosh. Stay with us. Joining us now in the studio is Dick Harrison. He's the Chief Operating Officer of Microtouch Systems of Wilmington, Massachusetts. Tim.
Dick, this technology is very similar to what we just saw on the PC platform, but we see it here now on the Macintosh. Can you give us an idea of how it works with the Mac?
I think it works pretty well with the Mac. You see, with the Mac and other higher power graphic user interface machines, it's quite easy to move things around and to pull down menus and that kind of thing.
Are you just clicking on by lifting your finger, you're clicking?
Yes, simply by lifting off, the mouse button goes down and then comes back up again. So,
in the same way with the Mac, I can just move these all over and move the cursor around?
Yes, exactly. In the case of the Macintosh, the nice thing about it for touchscreens is that our software driver emulates the mouse, so all Macintosh programs work automatically with the touchscreen. And basically what a touchscreen system is a touchscreen overlay like this, which is a piece of glass that fits like a big contact lens over the monitor, which operates together with a controller board that fits inside the monitor. And usually there's a software driver that operates with a DOS machine or Unix or Macintosh, Amiga, and so on.
And you provide that to an OEM or an integrator who then supplies the whole system, is that right?
Yes, exactly.
Okay.
Show us some applications that you've got set up.
Well, let's see. We have this one here, which is just an array of standard applications. And you can see just by pressing the buttons here, this happens to be a HyperCard demo. And this demonstrates a couple different type of applications that are pretty popular with touchscreens. Quite often, touchscreens are used in applications where a neophyte walks up to the computer and needs to use it. For example, in point of sale. A user in a fast food restaurant may order a cheeseburger.
And now it's interactive, isn't it? So
Yes.
he can then make the choices himself.
Sure. An apple pie and then ring it up and so on. In the case of, we'll demonstrate another use here.
How about the executive information?
Executive information is another one where an executive on his desk will want to have a lot of information at his disposal, but without complicated keyboard commands for access. So let's say he wants to know the information on the add-on manufacturing company here, and you can see what's happening. Another case might be ABC preferred stock, and you can see what kind of history that has had.
Now, your company has another little device that also works as a pointer. Can you give us an idea of how that one works?
Well, basically what we've done with this product we call the UnMouse is we've taken the touchscreen off the monitor and solved the ergonomic problem of holding your hand up for desktop applications by putting the tablet down on the desk. And you can see in this HyperCard application that by just pressing down a little bit harder on the unit, we're able to do the mouse button.
So in essence, my finger now is the pointing device.
Yes, exactly. And it operates in absolute mode so that it's very quick. If you want to jump to the upper left part of the screen, just touch in the upper left side, jump to lower right. So it's much faster than racing a trackball back and forth. Two important benefits are the conservation of desk space and ease of use.
Those are two big factors. The one thing that occurs to me is in 1984 we had Hewlett-Packard in here with their touch screen, and we've seen two touch screens today. What kind of standards do you see occurring in the touch screen industry?
Well, I think one of the benefits with the new graphic interface software is the touchscreens really are now ready to be popularly used. The standardization really just doesn't need to be there. In the case of the Macintosh, we're able to run all the programs directly with the right kind of drivers. We have a Windows 3.0 driver that runs Windows applications directly.
Okay, thank you very much, Dick. That's about all for our look at input devices. Stay tuned for this week's Computer News.
In the random access file this week, IBM is introducing two new top-of-the-line PS2 computers. The new Model 90 and Model 95 will be based on the Intel 486 microprocessor. The Model 90 desktop system will be the first to offer IBM's Extended Graphics Array, XGA. The Model 95 is designed to operate as a LAN server and for multi-user applications. Data General has introduced a low-cost, RISC-based desktop system. It's called the AV100, and it's designed as a graphics workstation. It can run at 17 million instructions per second. It's built around the 16 megahertz Motorola 88100 chip. The price tag, $4,000. Kodak has introduced a low-cost color inkjet printer designed to compete with Hewlett-Packard's PaintJet. The Diconix Color 4 printer can print text or graphics on plain paper and includes separate print heads for each color with non-smearing ink. It's priced at $1,500. And Kodak has announced a series of development tools and utilities intended to guarantee that color images on a computer screen look exactly as they'll appear when printed on a color printer. The package, called Photo YCC, actually calibrates the individual computer components, matching your monitor's color standards with those of your printer. Applications using the new Kodak color management system will be available next year. And MyGraph has released a hand scanner able to save 4,096 colors. The CS4096 requires at least 386 CPU and Windows 3.0. The scanner and software will sell for $795. Taking a look at this week's top 10 software titles for the PC, PC Connection reports that Adobe Type Manager for Windows 3.0 has jumped into the #1 position, followed by Quarterdeck's Expanded Memory Manager. In third place is PC Tools Deluxe with Facelift coming in fourth. In fifth place is Windows 3.0. Rounding out the top 10 titles are WordPerfect 5.0, Norton Utilities 5.0, Quicken, Procon Plus, and DeskView 386. Time now for this week's software review. Here's Paul Schindler.
Sometimes I prefer the dark. So does your PC. If you leave the same screen up all the time, it burns in. Now, lots of programs can automatically blank your Macintosh screen, but none can do it so elegantly as After Dark. It does absolutely nothing but come on your screen when there is no activity. It is so absurdly rich, it is fun and worth having. Everybody should have it. Each one of these screens has its own set of options. You have 30 choices. There are, for example, the flying toasters. You can control the number of toasters you have on the screen and the darkness of your toast. And of course, the sound of the flapping wings on the toasters is controllable as well. Talk about attention to detail, even the wings are reflected on the sides of the toasters. Now, this is my personal favorite. You can change the screen size from a very small one to full screen. You can change the resolution from little tiny squares to large ones. The number of knots determines pattern complexity. There is warp. There are fish galore, and there are these other eccentric options. I wish we had time to show all of them. After Dark is $40 from Berkeley Systems in Berkeley, California. For the Computer Chronicles, I'm Paul Schindler.
Fremont Communications is shipping a new kind of software which lets fax board users improve the quality of their fax messages. The Freecom Faxography TMLQ software translates application software output into fax image format. Documents can include boldface type, italics, and different font styles. Finally, for computer environmentalists, Maxis has released a new follow-up game to SimCity called Sim Earth. You can create your own planet from scratch or use one of 7 pre-designed planets. The games let you manipulate atmospheric and climatic conditions and even life processes while watching your planet evolve. If only it were really that easy. Well, that's it for this week's Random Access. I'm Kate McGargy.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SPA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix. For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio, 44240. Please indicate program date.